So we have 3 slides. Uh, One of the well-known, I would say, the not debate or confusion about the edge is actually how to start. Okay, for telco operators or CSPs. So most probably 2 years back, two architecture logics were proposed from the vendors. One is called standalone edge clusters. And standalone edge cluster, this means that, okay, you have a centralized cloud that have controllers and compute or worker nodes, OpenStack or Kubernetes or whatever. And then on the edge, you deal with each edge pop as a separate entity that can have like a controller or a compute, like a mini controller and mini compute. So that this is what are called standalone edge cluster. And let me just remind you that the investment on the edge can be huge because edge can be like thousands, right, of sites, hundreds of sites, thousands of DCs. So it's a painful investment. Okay, so you cannot just go and invest without making sure that there's a business case and there is like a well-defined revenue stream. The other option, and the name here is coming mainly from Red Hat, DCN, distributed compute nodes. This means that, okay, you can have your central cloud having controller and compute and workers, and you can start deal with edge as remote workers, like remote compute nodes, remote worker nodes in case of Kubernetes. So these are the two well-known approaches. There are maybe other approach like they call the device edge, which is one server that hosts everything. But I'm just focusing on these two because the CSPs are always evaluating these two models. And I'm here doing an assessment. We can do it together actually. The standalone edge clusters and the DCN. So from footprint perspective, CSPs see that, okay, I don't have to invest or to reinvest on controllers on the edge, and because that's most probably costly. So from footprint perspective, the option of DCN is really much better, where you can just deal with any remote pop as just adding a new compute node, like an expansion. From high availability and service impact in case of failure, so you see that the failure of centralized site in the standalone edge cluster, this doesn't mean that the edge sites fail. Okay, I know that centralized that center fails. That's a huge thing. But let's think about of disaster recovery or a disaster mode. DC is totally out of service. So if you lose the central sites or DCs, you don't lose the edge. While here in the DCN, if central DC controllers is out, then خلاص, you lose the connectivity with the edge. This doesn't mean that the service stops. Edge DCs can still handle traffic, right, in a way or another, but the communication, the dialogue, any kind of new adjustment, any kind of governance is lost. That's why we see the edge cluster, standalone cluster, as more giving better high availability. From operational perspective, they believe that in the DCN approach, because you have a central brain and you have remote workers, you can just do the automatic configuration, the ZTP, the infrastructure as a code, the expansions in a very classic way, the same we do it on central DCs. While in the standalone edge clusters, people believe that you may have to go side by side, DC by DC, if you don't have the automation framework in place. So that's why the DCN looks a little bit better. From scalability, adding a new POP in the DCN, just adding a new compute nodes, it's a very classical process. But adding a new POP in the standalone edge cluster require structuring the full DC controllers and worker nodes. Second thing, it's a brownfield case, and that's a very important, most probably because most of the operators, they have on-prem clouds, so they have a central stack that have controllers, right, in the central sites. So if they want to go to the edge as a pilot or as a testing, they always prefer the DCN because they say, okay, let's go like having 1 or 2, 3 DCs, okay, capitalizing on the investment that we did on the central sites, and let's see, right? So that's always the starting point for brownfield cases. While in standalone edge cluster, it's a perfect fit for a greenfield, but brownfield, it's always preferred to go to the DCN. From operational tools of FCAPS, again, because the central DCs, they have the connectivity to the OSS and BSS. So again, most of the operators, they want to capitalize on that integration because people working on that part, it's one of the lengthy, painful integrations to integrate with the fault management, performance management to the OSS. That's why from operational tools perspective, DCN somehow is preferred. For interlocks with orchestration, and to be fair, and that's my opinion, it might look like DCN is a good approach because there are orchestration stacks are there and we can just extend the orchestration capability on the edge. However, on the edge, it can be a sweet spot to welcome new players, startups, or new solutions for orchestration that can integrate to the OSS at the end, or the end-to-end orchestration, or the multi-domain orchestration, or whatever. So that's why I didn't give a higher weight to someone. I believe that both of them are okay with terms of orchestration. If it's a DCN, then you capitalize on the central orchestration stack and you extend the capability to the edge. If it's a standalone edge cluster, then you have like a new domain orchestration for edge, maybe coming from a new player, and then you integrate with the end-to-end scope. I have like 4 minutes. I'll just finish by this one because it's a very, very interesting. So if you go to study the case, for example, of AWS doing a partnership with Verizon. So first of all, if you want to get this service, you go to Amazon. So that's number one. So you as an enterprise customer, you like to go to Amazon, right? Because you are used to work with Amazon. So you can get edge services from Amazon the same way you get your cloud service, from AWS. So you go to AWS, and then you find that, okay, AWS is saying that we are there in these cities doing partnering with the CSP Verizon. Okay, so if you get the service from us, then you get it from Verizon. And from the definition itself, what AWS did, that they went to the, let me just find you the exact context, that they went to the CSP data centers at the edge. So they went to communication CSP data center at the edge, and they put their stack. Okay, so that you can get a full solution mixed by Verizon offering and AWS offering. But what is the good thing, and that's what I was stressing on, that when you get AWS wavelengths, you get these, right? You can easily get the machine learning SageMaker, right? You can get the AWS RoboMaker. So you get a full list of certified application on the edge. So it's not just a network part, an edge network part, a 5G part. No, you get a 5G from Verizon, but you get the whole list from Amazon, and that's Amazon environment, right? You can do anything under the title platform as a service. So that's the edge really that the hyperscaler they have, that they have a full stack of certified applications. They have a global presence globally. Yeah, imagine with me that if this customer get a service in Atlanta, and he has like a branch in South Korea, so he can get the same, because AWS is having the same partnership with an operator in South Korea, so he can get the same edge service in Atlanta and in South Korea. So that's a global footprint, and that's an edge of the hyperscalers on the compared to the typical CSP proposal, right? Because, for example, if I am giving, I am a Vodafone UK, giving a service, most probably it will be in the UK, right? But AWS or hyperscaler help CSPs to have this kind of global footprint or global delivery.